To prove triangle congruence, we already guided and gave it with three different postulates. And these three postulates are the items that we need to look at in trying to prove triangle congruence. So you don't need to look for other relationships, etc., etc. Just look for the different postulates in terms of SAS, triangle congruence postulate, ASA, triangle congruence postulate, or the SSS. We have these three triangle congruence postulate, and if we could actually uh, establish these three corresponding parts, any of these three, then we could come up with triangle congruence. Let's try to have this problem here in this practice exercise and try to find out which of these three may be present here. We have here this we are going to come up with a two-column proof. As I've mentioned before, it's always safe for us to use the given. So for this given triangle, XYZ, W here is a point on XZ, and we have constructed YW, making two different triangles from the original one triangle. And we will try to prove if triangle XWY is congruent to triangle ZWY. The two triangles, whether they are the two triangles formed by from the original triangle, whether they are congruent or not. So we are already given with this statement here as our preliminary given. So let's try to place it here. That's our item number. Let's have it item number one. I sorry. Yeah. And the reason is again given. Okay. And we need to reach this statement here. So probably, let me extend this further so that we could be guided. This is our goal here. And the reason that may correspond to this could either be SAS, ASA, or SSS, depending on the situations that we could come up here. Okay, so again, when we try to come up with our proof, we always look at the given. The given is the segment YW is a perpendicular bisector of XZ. So what are the other relationships that you would come up here? First, if it's a perpendicular bisector of XZ, that means W here cuts XZ into two equal parts, the XW and the YZ. We could now write here, let's have statement number two. Okay, we could now write the segment XW, okay, is congruent to segment, let's use ZW, so that we could use the corresponding parts here. So ZW. And what would be our given reason here? So for number two, you might say definition of a bisector, right? You could use that. Uh, Definition of a bisector. Or if you're not convinced with that, midpoint. Because when I say about why W is a perpendicular bisector of XZ, that would mean W is a midpoint of this segment here. So this is actually the first statement after the given, which is connected to that. And this corresponds to XW, I'm going to write here, and what W is congruent to WZ or ZW. Congruent meaning same measurement. And this corresponds to side. I already have side. So we have here S, S, and then S here. So from this, the three different postulates are still possible to come up here. What's next? Next here is we have a number two. This is in connection to our statement here, which is actually on bisector. How about perpendicular? When I talk about perpendicular bisector, aside from it divides the given side, the opposite side, it also creates perpendicularity with the opposite side. When you think about perpendicularity, the given angles now, this is now measure reason number 3. That means that these angles here produce, so the measurement of angle y is equal to 90 degrees, and the measurement of angle ZWY is also 90 degrees. The reason for this is the definition of perpendicular lines, or simply perpen sorry for my spelling, perpendicularity. And right, perpendicularity. Right? Since we have established perpendicularity here. So out from this, we are already exhausted the relationship on the given. So we cannot anymore establish a relationship of any other statements further to the given. But we could actually use the different statements next or after the given here. So in number 4, since they have the same measurement, we can come up that the measurement of angle XYW is equal to the measurement of angle ZYW. We just simply substituted here, right? So we could actually come up with the reason here, substitution, 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 or you may use the transitive property. Okay, and substitution or transitive property. Substitution means we substituted the value here, the 90 by this value, or use the transitive property. Two items are equal to the same thing. They are just the same thing. Okay, but this is not yet A. Do not declare that that is already your A, because when you talk about triangle congruence, the parts should be congruent, not equal. So we need to come up with a statement here, number 5, saying that the measurement, not anymore measurement, angle XWY is now congruent to angle ZWY. And this means we could actually use here the definition of congruent angles. Because when we say that if the measurements are equal, then they are congruent. So we have now congruent angles here, and this is now your A. Sorry, this is your corresponding angles. So you have S and A. So this is check, my A din dito. Therefore, SSS cannot be possible anymore. Yeah, that's the one way to trim down the possible support statements. So you don't need SSS because you have established already S and A. The next thing here is to determine if there is one more side to make it SAS or one more angle to make it ASA. Alright? Looking at the figure, okay, no more relationships here can be drawn from these statements. But what you can do here is actually look at the figure. If you talk about A, if you use ASA, that would mean ASA. This would mean that this side here, or this angle, must be congruent to this for you to use as a postulate. But we don't have given here to support that angle X is equal to as congruent to angle Z, nor in the given, nor in our statements here. We cannot capture that one. Therefore, ASA may not be possible. So if ASA may not be possible, let's look at SAS. SAS means SAS. Okay, because these are included parts. So this side here and this side is a part of triangle XWY and a part also of triangle ZWY. The same segment is part of both. In this case, we could actually use this number 6. Sorry, I wasn't able to make this red. Segment WY is equal or rather congruent to WY. If one thing is congruent to itself, that property is called reflexive property. Okay? And by doing that, we have established another S. That would mean we will not be using ASA, but we will use SAS. We have established already the SAS. That would mean the item that we are trying to prove is already our statement number 7. And the reason for that is the SAS triangle congruence postulate. We have already established a proof here for this given out from the given and all the relationships that we could look at. Again, when you're trying to prove for triangle congruence, do not say, I would like it to have SSS and I will look for a relationship for SSS. Or I would like it to have SAS triangle postulate. I will look for S and A and S. You don't you do not decide on the postulate at first glance. You need to decide that after looking at the corresponding parts, which could give you congruence. And then decide later on summarize it in terms of postulate. Because if I talk about triangle congruence, we'll always look at SAS, ASA, or SSS for triangle congruence. Okay, so you need to come to review this, check whether if I'm not saying this is the best proof, but some of you might trim it down to a lesser number of proof. Some of you might even extend this one. No worries about that one. The point here is that you could come up with logical proof. And at the same time, you could come up with connections between statements. And by the way, the last thing, yes, this is SAS, but it doesn't necessarily it doesn't necessarily follow that your proof should also always have SAS. What if in the middle you discovered two SS and an A, and you have found out that A is the included angle of that? So you, even if it looks like SSA, you don't have SSA triangle congruence postulate kasi. So even if it's look like SSA, it could still be SAS as long as the angle is a included angle, just like this one. There is an included angle of these two sides. Included angle of the two sides. All right. So next video will cover still on the proving, but we are going to extend it to another concept. Please stay tuned for that and please prepare. Goodbye.